Hello my dear students, today we are going to study computer organization and architecture subject, and the topic will be register transfer and memory transfer. My name is Himanshi Chaudhary, Department Computer Science and Engineering. Let's get started. In previous video we studied about registers. So let's recap. What is register? Register is a digital device that is very fast memory unit that may accept, store and transfer data or instruction. It means register is a digital device, that means it can store zeros and ones. It is very fast. It is a memory unit and it can accept, store and transfer the data or instruction. It is made of flip-flops. You may remember that this is the processor diagram, and in this these small blocks represents registers. Let's move to the next slide. Next topic is micro operations. So what are micro operations? You may have studied C language in previous semester, in which we do write the programs. It means if we want to add two numbers, you were writing C is equal to A plus B with the syntax of C language. When we are writing C is equal to A plus B, there are two operations, and that two operations are addition and assignment. C is equal to A plus B. A plus B addition. C is equal to, when we are writing, the result will be stored to C. Now let's see what are micro operations. The operations executed on data stored in registers are called micro operation. That means if we are performing any operation on register, these operations are called micro operations. It means if we are adding two values of registers, that will be termed as micro operation. If we are assigning one value from one register to another register, then we can say that this operation is a micro operation. Micro operation is an elementary operation performed on the information stored in one or more registers. It means whenever we are performing an micro operation, we can make use of one or more registers. When we are saying C is equal to A plus B, we are using three registers, and when we are doing C plus plus, it means increment by 1, then we are making use of one register. So this line states that whenever we are performing an elementary operation, then we can make use of one or more registers. Then it says the result of operation may replace the previous binary information of a register or may be transferred to another register. It means whenever there is an operation, just like again C is equal to A plus B, the result can be stored in any register and the previous binary information on that register may be transferred or deleted with the help of any other register. Examples of micro operations are counter, increment, load and bidirectional shift. Next is register transfer language. This is made of two words. Register transfer is one word and language is other word. So let's describe what is register transfer and what is language. Register transfer implies the availability of hardware logic circuits that can perform a stated micro operation and transfer the result of the operation to the same or another register. So what register transfer says? As you know now that register is a hardware device. So register transfer says that you will be having a hardware logic circuit and a micro operation. When this micro operation is performed on this hardware, the result of this will be transferred to the same or another register. It simply says that by transferring the data between the registers, we can make use of the hardware logic circuit and we can perform the micro operations and we can transfer the results to the same or another register. And what is language? Language word is borrowed from the programmers who apply this term to programming language. For example, your C language, Java language and many other languages. So what is register transfer language? It expresses the symbolic form, the microoperation sequences among the registers of a digital module. Now, in a digital module, if we are having two numbers on register that we need to add or perform any operation, for that we need to write some micro operation sequences, and that sequences will be written with the help of some of the symbols that we will study next. So this program will be termed as register transfer language. Now let's see what are these symbols are. Next is block representation of register. It will tell that how can we represent a register. There are many types of register. How to represent these registers in block representations. So all computer registers are designated by capital letters. For example, if we are having program counter, then it will be designated by PC. If we are having instruction register, then it will be designated by IR. If we are having processor register, then we will write R1, R2 or R3. If we are having memory address register, we will be writing MAR. This will be the designation for memory address register. These are the symbols which we were talking in register transfer language. Now you must always remember that if the register is n-bit register, there will be n numbers of flip-flops. Now let's take the example for any 8-bit register, that how to represent this 8-bit register in block diagram. R1 is the register which is of 8-bit. So this will be the representation of this register in block. 0th index will be on the rightmost index, and 7, that is the highest index, will be on leftmost position. You have to remember that the indexing of this n-bit register will start from 0 and will go up to n-1. For here it will be 8 minus 1, that is 7. So if we are having 8-bit register, it will have the indexing from 0 to 7. 0 at the rightmost position and 7 at the leftmost position. This is the block representation of 8-bit register. We can have 16-bit register as well. Example we have taken for PC. What is PC? PC is program counter register. It is a 16-bit register. So if we are having a 16-bit register, first of all we will divide it into two parts. It will have two parts, PCH and PCL. PCL is for the lower bits and PCH is for higher bits. This block is divided into 8 bits. 8 in lower one, 8 in higher one, and the indexing will be like this: 0 to 7, lower 8 bits will be in PCL, that is program counter lower bits, and from 8 to 15 will be in PCH, that is program counter higher bits. And overall we can say that program counter indexing will be from 0 to 15 because it's a 16-bit register. Next is information transfer. It will represent that how to transfer the information from one register to another. Now these are two registers. This symbol denotes that the data from R1 is transferred to R2. This symbol denotes a transfer of the content of register R1 into R2. The content of R1 will move to R2. This arrow is important here. This will tell that from where the data will move to other. Now, we don't always just transfer the data. We normally transfer the data whenever we are having some predetermined control condition. It means whenever we want to transfer the data, there will be a predetermined control condition, and if that condition is true, then only we will transfer the data. It can be written as like this: if P is equal to 1, then the data of R1 will be transferred to R2. So this transfer depends upon this P. Here P is the control signal which results in Boolean value 0 or 1. So it is to be remembered that only if when P is equal to 1, then only the transfer will happen. If P is equal to 0, then this transfer will not happen. Symbolically, for micro operation, it is written as like this: P, control function or control signal, colon. This colon is important. After this, that micro operation is written, that if this control signal is true, then this operation will occur. It's written, it symbolizes the requirement that the transfer operation be executed by the hardware only if P is equal to 1. Now we will see the control signal micro operation with the help of block diagram. In this block diagram, we are having a control circuit which decides the value of P if it is 0 or 1. On the base of value of P, this load is enabled or disabled. If this P is 1, this load is enabled. When this load is enabled, R1 is able to transfer the N bits to this R2. Now this circuit is synchronized with the clock. What is clock? Clock pulse is a time varying voltage signal applied to control operation of a flip-flop. And where are the flip-flops? These registers are made of flip-flops. So this clock is a time varying voltage signal which goes up and down. So these registers are synchronized with the clock. Now we will see timing diagram. In this timing diagram, here we are having clock in which time varying voltage signals are shown. Now before some time, this load is 0. This load cannot be enabled at every time. So before the time t where this will get 1. So at time t, let's suppose that this load is enabled. It means this P is 1. So at time t, this load is enabled, then this signal will go up for 1. Before that, it will be 0. Now it will take 1 clock cycle to complete the transfer from R1 to R2. So by the end of t, it means on the start of t plus 1, this transfer will be finished. So here we will say that transfer occurs at t plus 1th edge. It starts at t, but it is always said that the transfer occurs at t plus 1th edge, because at this time the complete transfer occurs. Complete bits of R1 is transferred to R2 by the end of t, that is the t plus 1th edge. Next is basic symbols for register transfer. These are some of the symbols, their description and example. To denote a register, we will write the symbol as letters or numericals. Letters will be capital. For example, this is MAR. This is memory address register, and this is processor register R2. If we need to denote a part of a register, if you remember, for program counter is of 16 bit. It is divided into two parts, PCH for higher bits and PCL for lower bits. So if we want to denote a part of register, then we need to use parentheses. For example, R2 0 to 7, these are lower bits. This can be written as R2L also. Now if you want to transfer the information, then arrow is used. Like here example, the data of R1 is transferred to R2. Next, if you want to separate two micro operations, then we will use comma. These are the two micro operations. By using comma, these can be separated. our next topic is memory transfer. Till now we were transferring the data from one register to another register. Now there could be the cases where we need to transfer from the memory or to the memory. Okay, so let's see the first definition of read operation. The transfer of information from a memory word to the outside world is called a read operation. It means whenever we are reading from the memory and transferring that data to the outside environment, then that operation is said to be read operation. Next, the transfer of new information to be stored into the memory is called write operation. It means if we want to write on the memory, we are transferring any new information to the memory, then that is called write information. Now, to write any micro operation, we must know the symbol to write the micro operation. So, this memory word is symbolizes as M to write any micro operation. It is capital because this language writes every symbol as capital letter. So, memory word is symbolizes by capital M letter. Now, whenever we want to write on memory or to read from the memory, we must know the address from where to read or what address we need to write. So, there must be some address. That address is written in the square brackets and this is the address register. The definition is to specify the address of M, that is memory. When writing memory transfer operation, address is enclosed in square brackets. Here AR is address register. We can write the read operation like this. From this address, the data will be read from the memory and will be written on any other data register that is outside this memory. So this is the read operation. When we want to write on the memory address from any data register, the content is transferred to this memory at this address. Okay, hope you understood that this is memory transfer. For memory transfer, we will use the capital letter M. In that, in square bracket, we will write the address. If we want to transfer the data from the memory, then we will write it like this. If we want to transfer the data to the memory, then we will write like this. DR is data register here. Let's move next. Next, these are some of the examples of arithmetic micro operations. These are the symbols and this is the description. To add two values of two registers, we will write R1 plus R2. If these are the nominated registers, then addition operation and the resultant will be stored on the R3 register. This means the content of R1 plus R2 are transferred to R3. Similarly, if we want to subtract R2 from R1 and store the result of this to R3, then this will be the symbolic representation of this micro operation. The content of R1 minus R2 are transferred to R3. Next, this register will be having some binary information. It could be 0, 1. This symbolizes the complement, and complements means if the value is 0, 1, the value will be 1, 0, opposite of the value what it was. Okay, so if R2 is having 0, 1 value, the complement will be 1, 0 and that 1, 0 will be stored on R2. If the value of R2 is 1, 1, what will be the opposite? 0, 0. Then 0, 0 will be stored on R2. If we add 1 to the complement of any register, then that value is 2's complement of the content. Okay, this is 1's complement. We are adding 1. Then this value will be 2's complement of the content of R2 and the resultant will be stored on R2. Okay. Next we are adding R1 to the 2's complement of the R2. What is 2's complement? 2's complement is 1s complement adding 1 to it. So this is 2s complement, and if we are adding one more value to this, then this is this equation, R1 plus the 2's complement of R2. If you will check, this is the subtraction operation and the resultant will be stored to R3. This is simple increment operator. 1 is added to R1 and the resultant is stored on R1. This is decrement operation. The 1 is subtracted by the value of R1 and the resultant will be stored on R1. Now let's revise once quickly. First we studied about micro operations. What are the micro operations? Operations executed on data stored in registers. These are micro operations. If you are adding two registers, that operation will be termed as micro operation. Examples are counter and increment. We learned here what is register transfer language. A register transfer language is that micro operation sequence of the symbols which tells that what we need to do in this program. Next we saw the block representation of register. If it is 8-bit register, then the lower index will be 0, higher index will be n-1, and this is the block representation of the n-bit register. This is 8-bit and this is 16-bit. If it is 16-bit register, then lower 7 bits will be the lower bits and it can be written as register name and in bracket L. If these are higher 8 bits, then register name and in parenthesis H for higher bits. Here we see that how to transfer information from one register to another. To transfer information from one register to another, we use this arrow operator. If this is condition based, which is normally it is, then the control function is written here, colon, and then that micro operation, that what next to be done. Then next we saw that about this micro operation, what is the block diagram and what is the timing diagram. Block diagram represents that based on this control circuit, the value of P is decided, and if this P is 1, then load is enabled. If load is enabled, it means R1 is allowed to send the n bits to R2, and this is synchronized with this clock. And what is clock? Clock is time varying voltage signal denoted by this, and at some edge the load is enabled, and at t plus 1 this load will be done, and we will say next that at t plus 1 the transfer occurs here. Next we see some basic symbols for register transfer. So we denote a register by capital letter and numerals. If we need to write a part of register, we use parentheses, just like lower and higher bits. If we need to transfer the information and we need to denote it, then we will use this arrow operator. If we need to separate two micro operations, then we can use this comma operator. Next we see the memory transfer. If we need to transfer the data from memory to any data register, then it will be the read operation and it will be written like this. If we want to transfer the data from outside to the memory, it will be write operation and it is written like this. Here AR is address register and DR is data register. Next we see the examples of arithmetic operation. This is addition, subtraction, complement, 2s complement, R1 plus 2s complement of R2, 1 added to R1, 1 subtracted to R1. Hope you understood, and thank you for watching the video.